All right, we are recording. This is 2.1. We're just going to cover the distance formula and the midpoint formula. Definitely feel free to interrupt me if you have any questions. Unit 2 is about graphing. And you don't need to graph things by hand. We're just using MyMathLab, and you can always input a coordinate pair to find that point on the graph. I also strongly encourage you to get to know the website desmos.com. You're allowed to use it on the exam, and if you don't have a regular scientific calculator, you can use it as a scientific calculator, but it also has a nice graphing feature that I use more often than I would use like a handheld graphing calculator. So don't hesitate to do that. So, all right. We graph on the Cartesian coordinate system, and it's a plane. That means it's a flat surface that extends forever infinitely in 4 directions, okay? We have discussed just a number line, right? With a number line, you have positive values and negative values, or you have increasing to the right and decreasing to the left in values, right? The Cartesian plane is basically just 2 different number lines. So you have your x-axis as one number line where everything to the right is greater than the numbers to the left, everything to the left is decreasing or less than, right? And then up and down, you have your y-axis. And it's more intuitive, where if you're going down, the number or the value gets lower. If you're going up, the value of your number gets higher. Good. They intersect at this point. We call this point the origin. And you can find any point on the Cartesian plane and give it a numerical value by using parentheses, a comma, and 2 numbers. Okay. The first number is where to go on the x-axis. The second number is where to find that point on the y-axis. Good. These 2 lines also divide the plane into 4 quadrants. Okay. You have quadrant 1 here. It goes in a counter clockwise direction. Just want to make sure. So behind quadrant 1 is quadrant 2, below quadrant 2 is quadrant 3, and then over here below quadrant 1 is quadrant 4. Okay. Again, you have points. Every point is 2 numbers separated by 1 comma. The 2 numbers represent distance and direction. The first is the distance and direction along the x-axis. The second is the distance and direction along the y-axis. So a positive 3 means from the origin, I moved over 3. Positive 2 means that from the origin, I moved up 2. And then where those 2 lines, if those were lines I was making, intersected is right here. So that's 3 comma 2. The 3 is the x value of that point. The 2 is the y value of that point. Good. So when you're looking at these points, it's basically the first number tells you how many units to go left or right. The second number tells you how many units to go up or down. Okay. I'll write it again. This is x. X means right or left. If it is positive, you go right. If it is negative, you go left. Okay. And then you have your y value, which is going to go up or down. Good. They are called points. They're called ordered pairs, or they're just directions, right? Or coordinate points. They're just directions, okay? So if we were to look at the point -3, 1, always begin at the origin. The first number tells us how many units to go right or left. Because it's negative, we're going to go left. The second number tells us whether to go up, down, or stay on the x-axis. That's also an option. If it was just y equals 0, we would stay on the x-axis. So it's a 1, so we're just going to go up 1 unit. Good. So the coordinate -3, 1 is just the location of the point, but it is also the way that we find the point. It gives us directions beginning at the origin, okay? What about if I had this point? This is actually the point 0, -4. Why is this the point 0, -4? Because on the x-axis, I did not move. I went 0 to the left, 0 to the right. On the y-axis, I went down 4. Good. And then maybe here, this wouldn't be 0, +4. This would be +4, 0. I went 4 to the right on the x-axis, and then I did not go up or down, so I stayed equal to 0 on the y-axis in terms of the y-axis, but I'm actually on the x-axis. So if you're on the x-axis, y is always 0. If you're on the y-axis, x is always 0. Good. So make sure you understand graphing points. Everything from Unit 2 comes from graphing points. It's going to take me a second. Resume recording. Share screen. All right, so we had the point 3, 2. Remember, this is just desmos.com/calculator. If you go straight to desmos.com, it will offer you a graphing calculator. It will say math tools. Here's where you get a calculator for the other units exams. For function calculator is even if this one's a bit overwhelming, you can just go to an even smaller one. But graphing calculator, here's where Unit 2, here's where Desmos can serve you for Unit 2. So we said the point 3, 2, right? I just put parentheses 3, 2, ended the parentheses. They put the point on here. I can also tell them to label that point, okay? I can put whatever I want into Desmos. 2x plus 9y equals 0. Or I can say 2x, or sorry, that's the same as the other one. I could say 1/2 x, or I could say y equals 1/2 x, which is the same line. Or I could say y equals x cubed, okay? Put anything you want into Desmos. That's all. Oh, let's talk about quadrants, sorry. -3, 1 is in quadrant 2. So the point -3, 1 is in quadrant 2. They like Roman numerals, but I always mess up Roman numerals, so I'm not even going to try it. Remember, that's x. That one's always y. So the numbers, or sorry, the point 0, 4, which we already talked about. Oh, no, we talked about 0, -4. 0, -4 is not in any quadrant. We just say it's on an axis. 0, 4 is on the, what do you think, x axis or the y axis? X is equal to 0, but it's actually on the y axis. When x is equal to 0, it's on the y axis. If I had the point -3, 0, now my y is equal to 0, so it's on the x axis. -3, but I did not go up or down. This one was 0, and then I went up 4. Good. And then I'll just give you one more, -2. No, I already did -3. I don't want to do -2. I'll do +2, -2. So my x is 2, my y is -2. I'm in quadrant 4. It's just a good thing to know in general. So yeah, I would just memorize 1, 2, 3, 4. Obviously very important that this is x and that this is y. Good. All right. So we said we were talking about distance and midpoint formulas. The distance formula is the distance between the x values squared combined with the distance between your y values of 2 points squared and then taken the square root of, okay? So what is distance? It's how far one thing is from something else, right? I can count it, it's in a straight line, I can go any direction on a graph, right? We're just talking about two different points and the distance between them, right? I want to count the distance between point A and point B, for example, okay? It doesn't matter if your points are actually in a straight line according to like very, very even, like the distance between 3, 0 and 3, sorry, between 3, 0 and 3, 2 would just be 2, right? But if they're kind of at an angle, it can be difficult to figure out the distance between them. So it does not matter if they are level with each other on the x-axis, level with each other on the y-axis, or if they're at an angle, the distance formula will tell you the distance between any 2 points on the coordinate plane, no matter what the points are. All right. You might notice this formula looks kind of complicated. That is because they are using what are called subscripts. Okay, do you see how there are 3 little 1s right here? And then there are also 3 little 2s right here. We call them sub because they're under the letter subscripts. Okay, so what this is saying is the distance between point 1 and point 2. That's what all of this says. The distance between point 1 and point 2 is equal to the x value of 0.2 minus the x value of 0.1 squared plus the y value of 0.2 minus the y value of 0.1 squared. So all of these little ones, these little subscripts under the p, under the x, and under the y just mean we're talking about 0.1, okay? So 0.1 will have the value x sub 1, y sub 1. The only reason for those ones is to denote that this is 0.1. This is not our second point, this is our first point, okay? 0.2, the little x and y values, x2, y2. Sorry, the coordinate points will have a subscript of 2. Good. Okay, so numbers that are small and to the right of the variable are just subscripts. D means distance. P means 0.1 for the first point. P2 means point number 2 or the second point. It does not matter, right? We've talked about this with absolute value. It doesn't matter if we're measuring from B to A or A to B. It's never going to be a negative number. Okay, so you can when you're choosing point A and point B, P1 can be A, P2 can be B, or P1 can be B, P2 can be A. Doesn't matter. You are welcome to mix them up, okay, when labeling them. Every point will have an X and will have a Y, okay? P1 will have X sub 1 and Y sub 1 to represent the ordered pair. So the distance formula is saying it is the square root of the 2 points X value, or the second point's X value minus the first point's X value, quantity squared, plus the second point's Y value minus the first point's Y value, quantity squared. Good. Let's practice. All we're going to do is we're going to label these and we're going to put them into the distance formula. Good. So I'm going to say P1 is 0, 2. That means that x1, oh, I hope I get this right. X1 is 0, y1 is 2. Feeling good about this? Have I made a mistake yet? I'm going to say point 2 is the 0.45. That means x2 is the number 4, y2 is the number 5. Again, you are welcome to say that this is P1 and this is P2. Don't worry about it, okay? Now, I have x1, I have y1, I have x2, I have y2. I'm just going to input them into this formula. The distance between 0, 2 and 4, 5 is the square root. X sub 2 is 4 minus x sub 1 is 0 squared plus y sub 2 is 5 minus y sub 1 is 2 squared. So all I did was label them, input them, okay? And you can just call it D. You don't have to say D of the 2 points. The distance is 4 minus 0 squared is just 4 squared, right? 5 minus 2 is just 3 squared. You can keep them in parentheses just to make a habit of it, but unless they're negative, it doesn't matter, right? So distance is the square root of 4 squared is 16, 3 squared is 9. So that becomes 16 plus 9 is 25. Oh, how convenient, right? The square root of 25 is 5. So the distance between 0, 2 and 4, 5 is 5. And they don't tell us the units, so you can just say units. Good. All right. The next one, same exact thing. I just decide what is P1. P1 is negative 4, 5. X1 is negative 4. Y1 is 5. Point 2 is the 0.13. X2 is 1. Y2 is 3. You don't have to do all these steps. It's just I make fewer mistakes if I do all these steps. So distance is the square root of x sub 2 minus x sub 1. So that's 1 minus negative 4 squared plus y sub 2 minus y sub 1 quantity squared. That means, sorry, no, I did have enough parentheses. 1 minus negative 4 becomes 5 squared. 3 minus 5 is a negative 2 squared, so I'm going to keep the parentheses around the negative 2. 5 squared is 25. 2 squared is 4, all under the radical. So it's the square root of 29. This is the simplest form because 29 does not have any factors, right? Or if they want it as a number without the radical, you could say it's 5.385, 5.4, depending on how they ask you to write it. Good. So that's how to use the distance formula. It will give you the distance between any 2 points. Here's an example of how to use it. Consider 3 points. A is negative 3, 1, B is negative 3, 4, and C is 4, 1. Plot each point to make the triangle ABC, find the length of each side of the triangle, and then verify that the triangle is the right triangle using Pythagorean theorem. All right. So sorry, my ruler is under my computer. All right, we have the points I'm going to plot the points. We said that we had the points -3, 1. So starting from the origin, -3 up 1 is point A. B is -3 up 4. And point C is 4, 1. Form the triangle ABC. Find the length of each side of the triangle. So here, I can just count, right? Between A and C I have, because they're on the exact same plane, they both have, let's put the points, -3, 1, and 4, 1. So I know that my y values will not change, right? That'll be 1 minus 1, which will be 0. The distance between -3 and 4, I can kind of just count, or I can subtract. 4 minus -3 is 7, or I can just count. Between here, 1, 2, 3, 4, 5, 6, 7, right? So the length of this side is 7 units. Good. Up here, B was -3, 4. So that shows us that they have the same x value. What's the difference in y between 4 and 1? That's just going to be 3, right? So we know that there are 7 units between A and C. There are 3 units between A and B, but since this is at an angle, it's not a straight line through on the x-axis or a straight line on the y-axis. We need to use the distance formula. It's not vertical, it's not horizontal, we'll use the distance formula. So the distance of line BC is going to be equal to, same thing, right? x2 minus x1 squared plus y2 minus y1 squared. Point 1 does not matter if you use B or C. I'll use B, -3, 4. Point 2 is going to be 4, 1. So x1 will be -3, y1 will be 4, x2 will be 4, y2 will be 1. We're just filling in the blanks. X2 we decided was 4 minus -3 squared plus y2 is 1 minus -4 squared. Oh, sorry, it's not a -4. I just wrote almost an equal sign, so it looked like a -4. All right. Four minus a -3 is just 7 squared. 1 minus 4 is a -3 squared. That's 49 and 9. So that's the square root of 58. Good. You could try to put it in simplest radical form, 58. It's an even number, right? So we can at least divide it by 2 and it becomes 29. So there is no way to factor 58 that would remove anything. It's in its simplest radical form right there. So we would say this is 3, this is 7, and we would just call this the square root of 58. Good. Then they ask us to use Pythagorean theorem. They're never going to ask you on the exam something that they don't give you the formula to. So the formula for the Pythagorean theorem is that leg squared plus the second leg squared is going to be equal to the hypotenuse squared. Good. Or a squared plus b squared equals c squared. We're not really talking about the points here. We're talking about the lengths of the sides. So we'll call the shortest leg a, so 3 squared. Second shortest was 7. 7 squared equals the hypotenuse, which we already found out was the square root of 58. Good. So 9 plus 49, sorry, and then you have to square it, equals 58, because squaring that 58 eliminates the square root symbol. 9 plus 49 is 58, so 58 is equal to 58, so it is a right triangle. Next, we have the midpoint formula. Midpoint formula is just what is half of halfway between -4, 5 and 3, 2. Good. The point in the middle of the two endpoints cutting the distance into 2 equal halves. Good. The formula for the midpoint M of a line segment from point 1 to point 2 is x1 plus x sub 2 over 2, comma, y sub 1 plus y sub 2 over 2. It's a little bit, I think, faster than the distance formula. So find the midpoint between -4, 5 and 3, 2. Let's just look at where this might be on the coordinate plane. So if I just made a coordinate plane and I said the point -4, 5, maybe right here, perhaps a little bit higher. And then 3, 2, it's going to be +3 on the x, +2 on y. What is halfway between this distance, right? So we have what we've been talking about would be what is the distance. But then the midpoint formula is going to ask us what is this point halfway through, halfway between this point and this point. Again, it does not matter whether you label this point, point 1, or this point, point 1. It's still going to be able to find the middle, regardless of which one is your P1 and which one is your P2. Good. All right, let's start with example 3. We have -4, 5 and 3, 2. Again, we're just going to say P1 is -4, 5. So x1 is -4, y1 is 5. Point 2 is 3, 2. So x sub 2 is 3. Y sub 2 is 2. Yes, of course, always. Good. All right, so no square roots. We're just basically, if you look at it, you're making a new xy. So those are two separate equations, okay? You can deal with them completely differently. This is one equation, and you put a comma, and then you have your second equation. Okay, so you can say the midpoint x value is x1 plus x2 over 2. Okay, so x1 was -4, x2 was 3, and we're dividing them by 2. Good. That becomes -1 over 2. So my first point, my x value of my middle point is -1/2. Good. It's okay if it's a fraction. Now, that was this one. Okay. Now I'm going to do my midpoint y value. That means I have y1 plus y2 over 2. My y1 was 5. My y2 is 2. 5 plus 2 over 5 plus 2 over 2. I got too excited and went straight to 7. Good. So that's the x value, or sorry, that's the y value of my midpoint. So my midpoint is -1/2, 7/2. Okay. Which time do I have? I'm going to show you on Desmos. All of those points. All right. So we're starting with -4/5. So sorry, -4/5. And then we had the point 3, 2. And then is the midpoint -1/2, 7/2? It looks like it, right? So you can always do that. And then our next one, we have -4, 3, and 2, 2. So point 1 is -4, 3. Again, x1 happens to be -4. Y1 is 3. Point 2 is 2, 2. So x is 2, y is 2 of point 2. That's fine. All right. Second example, but the exact same method, okay? So we're finding the midpoint x value. We're going to say x1 plus x2 over 2. x1 is -4. x2 is 2 over 2. -2 over 2. If you divide 2 over 2 divided by 2, you get 1. But it's -2 over 2, so it's -1 for x. Midpoint y is y1 plus y2 over 2. So you're just combining those points, cutting them in half. Y1 was 3, y2 is 2. 3 plus 2 is 5 over 2. I'll just write it a second time so that it's in the same column. So my next midpoint is -1, 5/2. And you can graph those, make sure that it fits with what it looks approximately correct, right? It's in the right quadrant. It looks like it's halfway between those two. All right, the last part of these examples is finding the midpoint, or sorry, using the midpoint formula, using the same formula, but instead of finding the midpoint, we know the midpoint, okay? We know that the midpoint is 5, -4, and we know that P2 is 7, -2, but we don't know P1. Okay, so let's write down what we know. I know that M is 5, -4. So that means my midpoint, let me see, XM. X of my midpoint is a better way to write it. The X of my midpoint is 5. The Y of my midpoint is -4. That is nothing, okay? And then I know P2 2 is 7, negative 2. That means my x sub 2 is 7. My y sub 2 is negative 2. And I know the midpoint formula, which is combine your x's, divide them by 2. Combine your y's, divide them by 2. All right. So if I want to find, I need to find my first point. I'm going to start with, I'm going to, what should I call it? X1. I think I should call it X1. Just trying to think of what to call it. All right. I'm trying to find X1, right? Trying to find X1, and then I'm going to try to find X2. So I'm going to say X1 plus X2 over 2 is going to equal XM, right? Now I'm going to replace all of those and solve for X1. X1 plus X2 is 7 over 2 equals XM is 5. Good? Any questions? So I'm using this guy, and I don't know X1, but I do know that my second X value is 7 and that it's going to end up as a 5. Now I can just work backwards. I can also just call this X if I want. You don't have to call it X sub 1. So I want X sub 1 alone. First thing I'm going to do is the opposite of dividing by 2, which is multiply by 2. Anything I do to this side, I have to do to this side. X plus 7, or X sub 1 plus 7, because that cancels that, equals 10. Good. Now I'm just going to subtract 7. That's still X. 10 minus 7 is 3. Good. So I'm trying to find P1, but I think X1, according to this formula, X1 is 3. What is Y1? So same thing for, oh yeah, I said I was trying to find X2, I'm trying to find Y1. Same thing for the next one. So X1 plus X2 divided by 2 is going to be the X of the midpoint. Same thing for the Y value of the midpoint. Y1 plus Y2 over 2 is going to give me Y midpoint. Now I can substitute in, I know Y2 is negative 2. So Y1 plus negative 2 over 2 gives me the Y of my midpoint, which was negative 4. I don't have much space, but I think I can solve it. Again, multiply both sides by 2. That leaves me with Y minus 2, or Y1 minus 2, equals negative 4 times 2 is negative 8. Y is negative 6, right? Because I'm going to add 2. So my Y is negative 6. Does that make sense? So we're not saying that -6 is between -4 and -2. We're saying that -4 is between -2 and -6. That sounds true, right? We're also saying that 5 is between 7 and 3. That also sounds true. We can quickly look at Desmos. So we said our midpoint is 5, -4. And then we said they told us P2 is 7, -2. And then we found 3, -6. That does look like that is between those 2 points. So we were using the midpoint formula, but as you'll see, we had to substitute in known information and solve for the x and y value of the third point.